Hello, welcome to another stream. How about that? But you didn't expect that. And today's random topic is generic programming. That's right. What is generic programming? So does anybody know what it is? Genetic programming is usually used for optimization problems. Or for example, you can imagine that you're writing AI for some sort of a bot. You generate random AIs for several bots. Let them play a game by certain rules. Then, after they play the game by certain rules, you can measure their performance. And their performance is going to be the cost function that you're trying to optimize. Then you take the best performing bot and breed the next generation. You introduce random mutations to the AI of that bot and let the next generation play again. Then you pick up the best performing bot and you repeat that process until the function does not improve anymore. You'll get AI implementation that's optimal, that has like a local optimum for a particular cost function. I'm gonna get that idea and I'm gonna just try to play with it. The first half of the stream is gonna be me implementing visualization and the game for which we're doing optimization. So does it sound interesting? I think I'm gonna go with the safest option for today, which is gonna be C. And for visualization process, we're gonna use SDL because this combination of technologies I'm the most familiar with. Let's create a separate folder. I'm gonna call it GP. It's gonna be usual C project and nothing special. Maybe main C. Let's actually quickly include everything. So here's going to be the hello world situation. And we're going to create a makefile. I have not come up with a name for the repo. I think I'm going to call it GP. I don't want to include WR because it causes more problems that I would like to. So I'm going to include debug information, use the relatively data standard. What else? Maybe I'm gonna make it pedantic, just in case. We're not using any lips right now. Let's try to compile this thing, and we're gonna git ignore this GP, and I'm gonna create this as a git repo. So then we're gonna do a committee. On top of that, I think I'm gonna start writing readme super quick. We're gonna have like a quick start. So a quick start, there we go. You have to do make, and then you're gonna just run it. Let's include everything. I'm gonna upload that to GitHub right away. Public, of course, let's not forget to make it public. What I'm gonna do, I'm gonna start with the visualization. We wanna actually be able to see what is going on. Let's use SDL for that. SDL.h, I think you have to do SDL init video, and then we're gonna SDL quit. The smallest SDL application that you can ever write. Packages. SDL2, package config, C flags, SDL2, package config, lips, SDL2. So let's try to compile that now. Can't find SDL2, I think it has to be like... After we initialized SDL, by the way, SDL can fail, so you have to always do things like, if SDL less than 0, that means, ooh, your SDL did a wacky. You have to do something like that. SDL get error, exit with 1. We're gonna have like agents that compete with each other, maybe for resources or maybe for survival, and we're just gonna let them play the Hunger Games. What they can do, they can find food in the environment, or they can eat each other. We'll optimize for how long a particular agent will survive. We need to create a window. First you initialize SDL, and then you create a window. So the title of the window is gonna be Hunger Games? Question mark. Then we have a position of the window. Initially it's gonna be 00, width and height, screen width, screen height. What kind of flags do I want to have here? I would definitely want to have like a resizable thing. If this thing returns null, we have to do this thing like that. Screen width 800, and this one is going to be 600. Const renderer. To create the renderer, we have to provide the window. Right, here's the window. And we have to provide an index. As far as I know, it's an index of the driver. We're going to use the hardware accelerated graphics here. Right. So there we go. And if renderer equal null, it's gonna be like that. Using GPU, exactly, we're gonna use GPU for genetic programming, how about that? I mean for visualization. But you already have an opportunity to say that I'm using GPU for genetic programming. But all you're doing, you're just visualizing it. Isn't this how you become like popular on Hacker News and stuff like that? Genetic programming is basically programming the same way as the nature programmed us. And we can use the same technique to program our programs using natural selection. Instead of writing programs directly, you just let programs compete with each other, devour each other, mutate and evolve over time. The program that survives is the program that you want. Let's actually start handling events. I think it had to do something like SDL poll event. Then we're gonna check event type. When we are about to quit, we're going to put this thing here. Then we're going to do SDL render clear less than 0. You know what? I don't understand why I'm not using my usual trick with a special function that wraps around all of this error handling. SDL check code, which accepts the code. Maybe it can return the code, but I'm not sure if it needs to be returned. Code is less than 0, and then if it's less than 0, we're gonna do something like SDL error. Yes, SDL get error. This is going to be an exit. We're going to just return the code. After that, I don't really need to do this kind of checks all the time. The only thing I have to do is just SCC. So, and every time I need to do this check, I can just wrap things around. Like, for example, here, I don't have to do that anymore. This is not going to work for functions that return pointers. So, a separate one for if ptr equal null. There we go. STD error. SDL get error. Exit 1. And we're gonna just return the pointer. So in here, essentially what you can do, you can remove this and do SCP like this. Now I can remove this as well and put SCP here. Render clear. I think you also have to set a render draw color before cleaning anything. So I'm gonna set the render color, and of course this thing can probably fail. So what's going to be the render color? So 150, 150, 255, and then we also have to swap the buffers, I think. It's not GL swap buffers. I think it's present. Boom. There we go. Should be working now. Should be working now. And there we go, we have a window. So we have a window that can do things and stuff like that. As already said, I want the game to be on a grid. Let's say something like board width. So how many cells on the board we're gonna have? Let's say it's gonna be 100 by 100. Board height is gonna be 100. We're gonna try to render that the grid of the board so we can see how it goes. Render board. It will only accept the renderer. We're gonna try to render that thing. Render board. I need to iterate all of the columns, iterate all of the rows, and just render lines. What am I iterating right now? I think I'm gonna iterate x 0 less than board width plus x. Interestingly enough, we need to know the size of the window. I wonder if I can get it somehow. SDL get size of window. Well, yeah, this is because this is not really a reliable variable because the window is resizable. It means we have to get the actual size of the window. Right, and to do that, we'll have to use this function, and this function accepts a window. But do I want to put a window there as well? Might be actually a good idea, because why not? And we'll have to provide the pointers to these variables and stuff like that. Int the edge. Now we have width and height. We need to calculate the size of a single cell. Wait a second. Why am I even doing all of that? So essentially, I actually solved that problem in something long time ago. What am I even thinking about? Jesus Christ. What you can do now in SDL, you can fix the size of the canvas you're drawing in and basically fit it into the window, and it's gonna like stay the same. Why can't we just use the same thing? This is exactly what I wanted. So that means I don't have to pass the window. I can only rely on hard-coded screen width. I can define the following things. So for example, cell width, screen width divided by board width. And that gives us the width of a single cell, but at the same time I want this thing to be a float. And cell height divided by board height, and there we go, render line. The x starts at x multiplied by cell width. This one is going to be 0, this one is going to be cell width, and this one is going to be screen width. This is the first line that we're rendering, y0, and we are iterating board height. In this case, it's going to be y cell height. There we go. Epic. So now we have cells and stuff like that, but they don't resize, but that's kind of the point. Render set logical size. Okay. As you can see, it basically embeds itself, and it also scales as it needs. To keep the cell squared, give it a squared size. We need to come up with the agents, right? So with the entities that play on the board. Let's call it an agent. Agent is gonna have a position, X and Y. How are we gonna encode the direction? In num and then direction. I think direction is too long of a name. I don't want to type it. They're also gonna have some sort of like a level of hunger, a level of health. We're gonna have actions that an agent can perform. Agent action, step, eat, and attack. When they die, they will drop food. Oh, by the way, another action could be nothing. Nope. Agents count. We're gonna iterate through all of these things. We can do something like a random agent, 0, and we'll need to initialize like a random values there. Random position is gonna be within a particular range. Random range. Random int range, let's call it like that. From 0 to board width. Y is gonna be like this. Random dir. Random int range is gonna be low and high. Oh, what's funny is that random dir is essentially random int range, and it's gonna be just 4. We're gonna try to find the distance between low and high by subtracting one from another, then generating from 0 to this value, and then we're adding low back. So random int range does not include high itself. The next step we probably want to do, we want to be able to render those goddamn agents. Render agents. I suppose we can just iterate over that. So it's going to be agents count. It's going to be agents I. So render agent. SDL renderer. I would like to render them as triangles. Unfortunately, SDL does not provide any way to render triangles. SDL set render draw color is going to be the renderer. I really don't like how we represent the colors. It's kind of difficult to, for example, define a constant for that particular color. If we had background color, and I could define background color like this, maybe even without the hash. SDL set color hex. And what this function will do, it will just parse this thing and use SDL set render color. First of all, quite important, hex len, strlen, exactly 6. Because I don't think we need to define alpha yet. uint8 parse hex byte, and it will accept char byte hex. So, and it basically makes an assumption that it can access the byte under the pointer and the next byte after that, and you're supposed to check that. So by itself, this function won't check that. Hex to dec, so you do byte hex, multiplied by 0x100 plus hex to dec, byte hex plus 1. We should be able to do the following thing, yeah, so we're also going to accept the renderer, parse hex bytes, so we're gonna parse the first byte here, then we're gonna parse the second byte plus 2, and then we're gonna parse the third byte plus 4. Then we're gonna have like this function, hex to dec. And here we accept an x character, and essentially, if x is less or equal and x less than 9, we can instantly return x minus z. If this thing is this, we're going to return a plus 10. Why people are so concerned about fast typing? I have no idea. Fast typing is usually never a bottleneck of software development. Only reason why I'm typing so fast is because I'm actually solving problems that I solved before hundreds of times. So I already know what I'm doing. Incorrect hex character. After that, it makes sense to, exit with 1. Error for alpha 255. Set color hex. So we provide a renderer, and I can do something like background color. And the background color is the same color as, for example, the background of my Emacs right now. And this is a grid color. It's gonna be what? Grid color. Okay, cool. Now I can define colors like a palettes using just hex colors. Let's generate something. So I like this one. Okay, useful for agents. I also like this one. What about this one? Do you think it's too bright? So... Baby powder is a color name. Wait, really? Yeah, apparently it is. I think it looks better. Yeah, render agent. We're gonna do SDL set color hex agent color. Well, at least I'm gonna try the red. We'll see how it goes. For now, I'm gonna render agents as the squares inside of the cells. It's gonna be rect. So the position is the following. Agent pos x multiplied by cell width. And cell width, by the way, is float. You have to keep that in mind, how to floor it and convert it to integer. Agent pos y, cell height. The next thing is cell width, and might as well actually do it like that. It's gonna be height. Every time we want to render something, we render board grid, then we render all agents. There we go. So we have 5 agents. We cannot render the board grid, and maybe that will also look good. Wait a second, why the am I using strings? And then I can do mathematical operations to extract the components out of it. Welp, explains why I'm unemployed. I mean, let's actually quickly fix that. It's kind of difficult for me to, you know, keep it. So I'm gonna quickly try to fix it. So here, what we accept is essentially uint32. To extract red, the first byte here, I need to shift the whole hex 3 bytes to the right, and a single byte is 8. Next is going to be hex. We're shifting only 2 bytes here, but also we have to mask out, because there will be garbage. When you take in this thing and you shift in 2 bytes, you get this thing, but then you have to get rid of this garbage, 0xff. For this one is going to be actually 1 byte, and for that one is going to be actually 0 bytes. Even though this kind of expression like pointless, this creates like a regular visual structure. You can see the idea here, self-documented code explaining what exactly it's doing. Everything works correctly. So look how much code we actually removed. Just extract the bytes out of the number. Just let the language do the work. I want to improve the look and feel of the agents. I want to make them triangles. But as a first step, I may try to just make them smaller. Agent padding, like 10 pixels. I'm gonna add this padding here, plus then minus. Agent padding. That was weird. It's supposed to actually subtract. We actually have to subtract it twice. We can control that padding, and now they even look a little bit better, I think, that way. Problem with these agents is that we cannot see their direction. But unfortunately, SDL does not allow to draw the rectangles, or does it? We can draw lines, and we can implement our own triangle rasterization. So I already did that in one of my games, so I might as well actually steal some code from there, so we can draw triangles. We're only implementing rasterization for the triangles that have a flat top or flat bottom. We just draw lines like this and we're filling it up. If you have some weird triangle that looks like this, you actually split it into 2 triangles and you rasterize them separately. This is usually how it's done, and this is basically what I'm implementing. I mean, I already implemented that, I'm just porting that from a different project, so I don't have to implement it myself. Even though re-implementing that from scratch would be interesting. First try. Who's a gut cooler here? Yeah, so there's no like anti-aliasing there. God damn it, it looks like shit because of that. I wonder if like with SDL GFX it's gonna look better. Let's actually find out. Let's try to install that. There's no triangles? Trigon. Let's use that. Oh, and they accept color as uint32. So the GFX actually literally implemented the style system that I reinvented here. What the f? And let's see if the quality of this thing is gonna be better. Okay, but it didn't feel them. Field trigon. I think the quality stayed as it was with my code. AA polygon. Yeah, first of all, it's not field. And it's trying to do some anti-aliasing, I suppose, but it doesn't really work. Just render 2 triangles, 1 field with... Wait a second, wait. I mean, you're probably joking, but that might actually even work. Even though they're rendered as triangles now, they are not rendered according to their direction. I think I'm gonna save triangular meshes into the arrays, or directions array. I'm gonna have 4 of them, 6 numbers. X, Y, X, Y, X, Y of the 3 points of the triangle. And there we go. Defining such mesh on this kind of coordinate system is going to be super easy. The first point is 0, 0. The second point is going to be x is 1, but y is going to be half. The last point is going to be 0, 1. The next one is going to be up, and it's going to be something like this. So this is 0, 1, x, 0, 5, but y is going to be 0. Then this is 1, 1. The next direction is left, 1, 0, 0, 0. Okay, I think I defined all of them. If you have a direction, you just pick the corresponding mesh, scale it, shift it, and render it. And that gives us that mesh that I would like to copy somehow. By the way, if I do something like this, where I have like 6, will that actually copy the array? Invalid initialization. Okay, so that makes sense. So I'll have to literally do things like that. x1, y1, x2, y2, x3, y3. Because we'll need to scale these things at some point. 1, 2, 3, 4, 5. So if it's an x, cell width to every x, every y, we have to do a cell height. And there we go, we have a scaled mesh. How we're gonna move it? It depends on the position. Agent pose x, and for y, it's gonna be pose y. Scaled and shifted mesh. I should be able to do the following thing: x1, y1, x2, y2, x3, y3. Looks good to me. An intentional rhyme, by the way. And I might as well actually take the whole thing here and just boom, boom. Will that compile? Will that compile? We'll see. Oh, that didn't work. Well, at least they are rendered in different directions, sort of. I have to multiply these things by their corresponding sizes, like this. Yeah, so now they're looking in different directions, but what's funny is that there's no other directions. The question is why? I don't know. We can try a very interesting thing, essentially. We can have agents count equal to 4, and when we initialize in the agents, we can assign their direction to I, and that will check all of the possible directions. So let's see if it's gonna work or not. Yeah, there we go. They're as big as the cell itself. We'll have to scale them down a little bit. I'm gonna define agent padding. It's gonna be like this. What we have to do here, the scaling has to be slightly smaller. We're simply gonna subtract twice of the padding. That makes it a little bit smaller. We can test it. So as you can see, it made them a little bit smaller, but their position is still not aligned with the center. And to align it with the center, we have to add a little bit of padding there. Add agent padding. And now they're aligned, and now on top of that, what I can do is I can increase the padding, for example 20. Yeah, there we go. I suppose now we need to come up with a brain for the agent to encode the logic of a particular agent. The way I want to encode the logic of an agent is actually quite similar to Turing machines. Each agent have internal state, and state is going to be integer. So this is the state integer. The behavior of an agent is described by a table where we have the current state of the agent. What do they see in front of them? Do they see a foot in front of them? Do they see an other agent in front of them? Or do they see an empty cell in front of them? Here's the table. First thing here is going to be state, environment, what action the agent have to perform in this particular situation, and what state it should switch to after performing the action. The whole brain of the agent is going to be a sequence of these things. The current state of the agent, what it sees in front of it because it has a direction, what action it has to perform, and how to switch to the next state. If there is no such combination, it will always perform, let's say, nothing. It will literally do nothing. And that way of describing the behavior will make it easy to mutate the behaviors and apply genetic programming. I hope so. I've never done genetic programming in my life before. I borrowed that idea, by the way, from a Turing machine. Initially, I wanted to apply genetic algorithm for Turing machines, but then I thought that maybe it's not that interesting. So something like actual living creatures that fighting, playing Hunger Games would be a little bit more interesting. What mutations are going to consist of? Mutations are going to consist of adding a new row into this table, or maybe removing a new row, maybe adding an additional state, maybe removing the state, and so on and so forth. We have to be careful so the agents don't go into the state from which they can never escape. Maybe the next state is going to be something like 3, but state 3 is never mentioned anywhere in the table, so they reached a hold state in which they cannot do anything. We may actually allow that if you think about it. Maybe some of the agents that may reach such an inescapable state will never survive. The next step is going to be actually coding this table. Then we're going to use our visualization to see how the agents behave with a certain table. To be fair, maybe the agents also have to be aware of themselves, like how much hunger they have and how much health they have. But it may make it a little bit too complicated, so I'm not gonna do it for now. Basically, each agent is a small Turing machine that works on 2 dimensions, because Turing machine works in a single dimension, but this one is gonna work on 2 dimensions. We can code a single row of the table. So it's gonna be type def. You missed the surprise. Do you guys have a surprise? I'm so sorry. I'm so sorry. Thank you. Thank you so much for the surprise. It's actually a good surprise. I'm so sorry. Thank you. Thank you so much. Okay, so let's define a row. I want this thing to be called agent brain. So this is an agent brain. So that thing is a brain cell. It's a single brain cell. Basically, we have a state. Then we're going to have an environment. It's basically what the agent sees. And what agent can see. Type def and so I'm gonna just call it env. Environment is gonna be env nothing. We see nothing literally in front of us. We can see another agent and we can see food. Then what kind of action we can perform and the next state. And then we're gonna have a brain. Type def struct. Brain is a bunch of brain cells. It's gonna have a count. Flexible array member cell. Yeah. Here's the brain, and the agent, I suppose, is gonna have a particular brain. This is an agent state. This is its brain. Okay, everything's compiling. I think it needs to be organized somehow, like better. Or maybe we should have something like the game itself. And the game itself will store all of the agents. Also, it will store the positions of all of the walls and the positions of all of the foods. The only thing we're expecting from this genetic algorithm is to learn that if you see food, you have to perform action it. If you see wall, you have to try to rotate or escape it. If you see other agent, you have to try to attack. If they can learn at least that after like a little bit of randomization, that would be actually pretty cool. I want to define something like position and whatnot. So it's going to be pause. Oh, wait a second. For the food, we also need a marker that food does not exist anymore. And for the agents, we also need markers that it's dead. So let's introduce food. Food is now countable. Alright, foods count. If the enemy dies, it will drop the food. The agents won't be able to instantly eat each other, they have to first kill. So, and the food right now has a marker, whether it's eaten already. If it's 0, it's not eaten yet, it also has a position X and position Y. We don't have walls yet, that's what's interesting. Let's introduce wall, why not? So it's gonna be wall, and wall is basically gonna be just a position. Walls count. Let's implement something like render game. Probably constant pointer, because rendering is not gonna modify it. So we're rendering agents, but we're taking agents from here. How are we gonna render food and walls? So we also need something like init game. It's gonna initialize the agents. I'm gonna just allocate an instance of a game here. Initialize it with 0, then I'm gonna initialize it, and then render game like this. So what's gonna be the next step? I think we should have a way to step the game, to go to the next iteration, a simple step of the game. And I wonder how we're gonna step the game. We might assign a special key for that, SDL key down, so every time you press a key, it's gonna step the game one time. Key sim space break is gonna be a step game. So step in the game, so we also need to draw the foods and walls. Let's iterate through food. I position X is going to be a random int range from this thing, then Y is going to be height. Similarly, we're going to have a random position of the walls, and this is supposed to be walls. Okay, we do initialize them, but we don't render them, that's why we cannot see them. So we're going to iterate through all of the walls. Walls count. Plus I, SDL rect, position of the walls. Pause X, but it has to be multiplied by cell width. This one has to be multiplied by cell height. I'll have to floor it. SDL set color hex, and we have to provide the renderer, and we're gonna say wall color, the same color as the color of the grid, and then we're gonna provide this rectangle here. Okay, so here are the walls. The next thing we need to render is the food. Do we have circles? We do have circles. We can render them. Foods count. Plus I. Okay, so here's the function that I want to call. I need to calculate the position. We need to find the center. Food I position x. So I have to multiply it by cell width, and I have to add half of a cell width. So then we're gonna have a radius, and the radius is quite important. So this one is gonna be y, height. I think radius is gonna be probably minimum between cell width and cell height, and maybe we subtract the foot padding. I want a floor full of that. I think there's f min f. Foot padding is going to be the same as agent padding, so might as well actually just indicate that explicitly, because why not? And I guess I did a wacky and a little bit of oopsie doopsie. Why are they transparent? That's really strange. So first of all, the radius is actually too big, so that means I'll have to divide it by 2. It looks a little bit better, but I don't understand why it is transparent and why it is not the correct color that I specified here. It's supposed to be green. RGBA, probably. That's actually kind of bad. Because, wait, seriously? So... Oh. We're gonna go ahead and fix that. Okay, I can change it like that. Let's try B. GRA, maybe that will actually solve that? No, it's completely wrong. I'm confused. I'm streaming for 4 hours and I'm tired, chat. Maybe we can download the source code of GFX and look how it is defined there. That would be kind of interesting. For now, I'm gonna actually use RGBA. We can just reverse this entire thing. It's gonna be 3210. And overall, I think it works, except for the circles. I think circles have a different format or something. Do they, in different functions, parse this color differently? I'm really curious. Let's actually find out. Isn't it docked in, I don't know. Who reads documentation in 2020? Come on. I'm gonna try to find the function field circle color. Here's the implementation, what it uses, okay. And I was thinking about how do I parse uint32, bit shift, you know, masks, and like that. Who cares? Just cast it to a byte array and just... Now that's a big brain time. You want to see Chad versus Virgin? Virgin bitwise operations, Chad type punning. So anyway, it is done like that in field circle color. How can you trust the docs? You need to read the source code, because you may have discrepancies and stuff like that. So they parse it the same way, okay, sure. Yeah, everything is passed like RGBA. This is one of these multi-stream Friday. One stream is not enough to explore this idea, because I was setting everything up for the whole stream. We're gonna continue doing that the next time. Thanks everyone who's watching right now. I really appreciate it. That's it for the day.